Okay, so moving on to some more surface area. We're going to talk about the surface area of pyramids and cones. So what I got here is a cone. For some reason, people screw this up all the time. They confuse cones with cylinders and pyramids with prisms. So remember, a cone is like an ice cream cone that you eat out of, like a sugar cone. And a pyramid is the same thing that's in Egypt, except the ones in Egypt are different than this. This is a triangular pyramid. The ones in Egypt are square pyramids because the bases are squares. Okay? And we're going to talk about how to find the surface area of these things. But we got to get some terminology under control first. So that is a square right pyramid. It's called a square pyramid because the base is a square. It's called a right pyramid because the vertex, this little guy up here on top, is directly over the center of the base. When you have a right pyramid, they're a lot easier to work with because then all the lateral faces are identical. What shape are those lateral faces? Nathan?
Isosceles triangles.
Thank you, isosceles triangles. You find one of them, you can find all four. This distance from the vertex down to the base is called the height. Sometimes also called the altitude. And we use capital H for that. So nothing different than a prism. However, we do have to introduce this other distance, which is represented in green, and that green is called the slant height. And we use an L. It's actually a cursive L to represent that. So the weird thing about the slant height is the slant height is the slant height of the pyramid, but it's the height of the triangular faces. So when we're calculating the area of that triangular face, we're actually going to need to find the slant height because, as I said, it represents the height of the triangle. So on the triangle, it would be lowercase h. On the pyramid, it's lowercase l. And I don't know why they use an L for it, other than S was taken and H is taken. If the vertex is not over the center of the base, then we get something like that, which is an oblique pyramid. We're not going to do a lot of work with oblique pyramids because it gets pretty nasty. Especially since now, as soon as you move that vertex away from the center of the base, you have 4 different triangles to deal with.
And they might not be isosceles.
I'm sorry?
They might not be isosceles.
They are not isosceles. All of them can't be, can't be, I have the hiccups. Cannot be isosceles.
There can be one isosceles.
Correct. There can be, doesn't have to be. You see the term regular pyramid there. Regular pyramid refers to the shape of the base. So if the base is a regular polygon, then we would call it a regular pyramid. That's a regular right pyramid. It's actually a regular square, or you could say a square pyramid. Square pyramid and regular quadrilateral pyramid are the same thing. But you'll see we'll deal with pyramids that have pentagonal bases, hexagonal bases, and we need to know, is that base a regular polygon or just a plain old silly polygon? Okay, what's the net for that thing look like? Draw one. Remember, a net is a 2-dimensional shape, not a 3-dimensional shape. And also notice how many sides the base has. most people are drawing it like a flower or a ninja throwing star. However, there are a couple variations. So most people I saw did this. Right. A couple variations. I saw something like this. Somebody took the pentagon. Whoops. Let me try that again. Took the pentagon, put one triangle on it, and then brought all the triangles off of it. 1, 2, 3, 4, 5. That would also work. Stand that one up and then fold all the other ones around. So notice that in the pyramid there's only one base. That's a common mistake. One base and 5 sides. Unlike the prism, which had 2 bases with all the lateral faces. And the lateral faces here are triangles. Again, I would encourage you to find the surface area of this puppy by breaking it into its shapes, but you can use a formula if you'd like, and that would be the formula. The problem with that formula is that it only works if you have a right pyramid. What's capital B stand for?
Area of the base.
Area of the base. P,
Perimeter.
perimeter, and L,
Slant height.
slant height.
So the slant height is just the height of one of the triangles.
Beautiful. Yes, sir.
That formula works for like any kind of pyramid that's right, so like a right square pyramid or like a right pentagon pyramid. So that works for any of them? Okay.
As I mentioned, the technique that I prefer, which you can use whichever one you want, is just to find the area of those 6 surfaces and add them all up. Either one is fine as long as you show your work adequately. So let's do that one. Find the surface area of, find the lateral area of that square pyramid.
And so if we wanted to find the area of like the pyramid with the pentagon bases, I mean, then we have to do the like drawing the triangles.
Yeah, you gotta do the pentagon thing. I got one of those coming up, it'll be fun.
Yeah.
Mr. Reed,
Yeah,
so the lateral area is all the triangles added up, right?
yep, without the base, no base. Sometimes I'm all about the base. Don't look at me like that, Amber.
Just thinking.
I can be all about the base.
Are you?
No treble. Wow, smell that stink eye over here.
One side.
Answer? No. 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 Yes.
25.
25. Why?
Well, I did,
Yeehaw.
I used the area formula for a triangle, which is 1/2 base times height.
And the base was how long?
The base was 2.5.
And the height is
5.
beautiful.
And then I got the area for one triangle was 6.25, and I multiplied that by 4.
Hot diggity, well done. Notice again that the slant height of the pyramid is the height of the, yes, sir.
Can you write that process down on there?
I'd be happy to.
Thank you.
Welcome. She found the area of one triangle that has a base of 2.5, a height of 5, and we all know that the area of a triangle is 1/2 base times height, so she did 1/2 2.5 times 5, which is 6.25 times 4 of them, because there are 4 of them, gave us 25 square centimeters.
Okay.
don't seem happy about that.
I was trying to do surface area, I'm like, whoa, what?
No,
Yeah.
surface area. In this case, we're not about the base.
Okay.
We're solid? Hot diggity. Find the surface area of that one. This will be fun. It's a regular pyramid, so that base is a regular polygon. What kind of polygon is that? It's a hexagon. We are, however, missing a crucial piece of information. What are we missing? Slant height. For those of you that are visual learners, we're looking for that guy. So, notice that this is the slant height. What about that guy? What's that guy? That guy right there. I'm sorry?
Apothem.
It's the apothem, correct. Woo-hoo-hoo. How long is the apothem?
4 times square.
Again, we can do the whole triangle thing from the hexagon, but as I've mentioned a number of times, a hexagon is simply an equilateral triangle times 6. There you go. An equilateral triangle times 6. So I'm going to do the area. Nope, I lied. Get rid of that. I'm going to do the base as 6 times s squared square root of 3 over 4. And s is 8, so 64 divided by 4 is 16 square roots of 3, and 6 times 16 is 96 square roots of 3. That's B, the area of the base. Now I got some triangles. What's the base of those triangles? 8. I need to find the height. This length is the same as that length. How do I find it? Cricket. How do I find it? No. How long is this?
4 square root of 3.
4 square root of 3. So how do I find that? Animal. Pythagorean theorem. We'll do it up here. I got some 12 squared plus some 4 square roots of 3 squared, giving me L squared. Ooh, that looks cool on the black. What's 4 square roots of 3 squared, Natalie?
48.
Yippee-ki-yay. 4 squared times 3 square root of 3 squared. So that's the square. L is then equal to the square root of 192. Ooh. I'm going to leave it in that form, though, because I'd like my answer to be nice and correct at the end. So therefore, the area of this triangle, 1/2 base times height, which is 1/2 8, times the square root of 192, times 6, because I got 6 of those puppies. That's 24 square roots of 192. This is important. This is important. Add those up. I would not give that as an exact answer. I would.
Let's go take a photo, sorry. Is that cool?
Photo of what?
This.
I would not give that as an exact answer. I would add that up and get an approximate answer. Whatever 96 square roots of 3 plus 24 square roots of 192 is. This probably even simplifies, I'm not sure. George?
Oh wait, I was wondering why you multiplied by 8. Is that was the base? Okay, I got it.
Any other questions before I erase? Okie doke. Oh, I guess it does simplify. 288 square roots of 3, or whatever that is, decimal equivalent. Cones. How many faces does the cone have? Hold on, let's back up before it gets ugly. How many surfaces does the cone have? 2. How many faces does the cone have?
1.
1? 2.
1.
1.
3.
Not 3. That one I won't accept.
1.
We're missing the other one for the argument.
Infinite.
Thank you. Infinite. 1. No, 2, 3. No, not 1. What were the answers? 1, 2, or infinite. Awesome. Draw a net for that cone, please. Many of you got a good start with a circle and then ran out of gas. Is that bottom curved? Curved this way? What do you got going on there? Okay.
That's not the whole thing though.
Oh,
Yeah.
we're in transition period.
Yeah.
Okay.
Yeah.
No, that wouldn't work very well at all. That would work okay for the
Yeah.
base. Yeah, this not so much
Yeah.
for the lateral surface. Kind of hard to fold a segment up into a cone. Couldn't get a lot of ice cream in that. Or you could get an infinite amount of ice cream in it, depending on how you want to look at it. All right, so I see some interesting possibilities here. Common answers, we got this one going on. This looks like Napoleon. We also have this one. And the third one I saw was this one. What do you got?
I was thinking like, when those magicians make those like newspaper like cone things, like they pour milk in.
Yeah.
It doesn't
Yeah,
start
when they
with
pour the
a-
whole gallon, it just doesn't, it goes nowhere.
Don't they
Classic
start
trick.
with like a rectangle?
You know how that trick's done, by the way?
No.
You'll notice when you do that, when they do that trick, they never actually empty out the entire pitcher. They'll only pour like half of it. It's actually a pitcher within a pitcher. So when they pour the milk, instead of running out of the pitcher, it runs back into it.
Oh yeah.
So they take like a full amount and then it reduces it by half because it's inside there.
Yeah.
It's a classic trick.
But anyways, when they make the cone out of the newspaper,
Yeah.
doesn't the newspaper start like?
Yeah, but that's
like,
different because they're
couldn't you, like,
overlapping
fold-
it.
Yeah.
Because I could
Oh.
take
Okay, I thought you could overlap it.
I
You
could
can't
take a
overlap it?
no, you can't overlap it. I could turn this
Yeah.
into a cone. So they do something like this and then they
Yeah.
pour the milk in.
You
Yeah.
can't overlap.
No, can't overlap. Any others? No? Okay. Raj, what'd you do? Did you take like a pentagon and do some origami and turn it into a bird and then chop the wings off the bird and then you have a cone?
Sure.
Okay, good. What do you got?
All three of those work.
Oh, I didn't say that.
Oh, I would like this circle with a rectangle.
Rectangle doesn't work. Cylinder, because that would make a cylinder.
Well, you don't have the top on, so you just. Oh, you
You
can't
have-
overlap, can you? No.
Anything else? This one won't work, because this won't allow it to close. This one, I'm still thinking of. This would actually make a cone, but it wouldn't make a right cone. It would make an oblique cone. That would make a cone. And I don't think anybody got the other one. The funnest one is this. Come on, here we go. There it is. That right there. Nope. Wrong slide. Sorry. Oblique cone. Did you get all that other stuff? Height, slant height. How many slant heights does a cone have?
Infinite.
Infinite, good, because you can measure it anywhere. So you got a height, you got a slant height. There's an oblique cone. That's what you'd get if you used a triangle. But
Where's the slant height?
all the blue,
Okay.
anywhere down the side. The one I wanted was that guy. There you go, Pac-Man with a growth.
The what?
With a growth. It's got like a tumor or something. Something growing off the back of his head. Don't stare at it though. He's self-conscious.
Oh, that's a good one.
A good growth? Is there any such thing? How would you distinguish a good growth from a bad
I
growth?
wasn't talking about the growth, I was talking about the.
Oh, you're talking about the net itself.
Yeah.
Oh, okay.
Wait, what does that look like? Like, how do you fold that?
It looks like Pac-Man.
Looks like you just like missed one of the things. He was a little off.
Yeah, you missed one of the, what are those things? Food pellets or whatever?
Food pellets?
I don't know, what are they? He's eating them. What else would they be?
I thought they were like
The ghosts.
little, yeah, they're like little ghosts with names.
Oh no, the cherries. They're like.
No.
No, there are white dots that he runs around the screen
The
eating.
majority of
Oh,
Waka,
I
waka,
think
waka,
I
waka,
thought they
waka,
chase
waka,
him.
waka. And then ghosts chase him
Yeah.
until he eats a cherry, and then the ghosts turn
No, the
ghosty, and then
cherries
he
is like
can-
extra.
Big
Extra
one.
big
No.
blinking dots are.
Oh, is that? Yeah, you're right. Cherries are bonus points. Yeah.
No, how do you fold this into a cone?
Yeah.
Great question. Amber wants to know, how do you fold this into a cone? So to answer that question, I'm going to ask you a couple questions to go along with that. What's the significance of that distance? The outer epidermis of the Pac-Man, or the man of Pac? What?
The circumference of the circle.
It is the circumference of the circular base. What is the significance of this distance? The slant height. So to fold that, I would cut it out, and then I would bring these two pieces together, and I would get a little bitty cone. Okay? What's the difference then between that and the hat-looking thing? The guy with the big hat on his head. They'll both make cones. How do the cones differ? Nope. No, that'd make a nice right cone. Tall, skinny cone, short, fat cone. Okay, the smaller the sector, notice this is a sector, this is a sector. The smaller the sector, the skinnier the cone, skinnier and taller. Okay, so I'm going to contradict myself here and say that when we're looking for the surface area of a cone, the easiest way, and probably the only way that I'm going to show you, is to use a formula. Because the other method is too nasty, and I don't know why that just happened. Okay, let's try again. I can use my own technology. There we go. Surface area pi r squared, that's the area of the base. And then the lateral area is pi rl. So when you're looking for the lateral area of a cone, you have to use pi rl. The derivation of that thing is too complicated to use on a regular basis, so we're just going to go with that.
If it asked you to find the lateral area, would you just do pi r?
Pi rl. So L is pi rl, S is pi rl plus pi r squared. Okie doke. Find the lateral area of that guy. sure you understand the distinction between the height, h, and the slant height, L. Lateral area involves the slant height, not the actual height. What is L in this case? 20. 12 squared plus 16 squared equals L squared, which is also a 3, 4, 5 triangle times 4. So this guy is 20. Whoops. Sorry, itchy trigger finger. This guy is 20. And therefore, this one just becomes a plug and chug. L is equal to pi RL. Pi times the radius, which is 12, times the slant height, which is 20, gives us 240 pi. Feet squared. I get sloppy there. Include the units. Then if I wanted the surface area, what would you add on to that? Which is? 144 pi, correct. This isn't very exciting. Let's skip it. We're done. Okay. Biggest mistake that people make is tonight will be okay. Tomorrow is going to get a little shaky because when you start merging these terms, people screw up on the terms. When you have to distinguish between cylinder, cone, pyramid, and prism, everything goes to heck in a handbasket. So make sure you understand the difference between those, especially if you're a formula person. You misread the problem or misinterpret the shape and use the wrong formula, you're dead in the water. Okay? Question in the back?
So the difference between a triangular prism and a pyramid is the right pyramid the right.
No, it's a completely different shape. This is the triangular pyramid. Triangular prism was the thing we did yesterday, which looks like a triangular tube. Prisms look like tubes, pyramids look like pyramids.
Okay.
Things in Egypt.